In this video, we will talk about errors. In this video, we will talk about type 1 error, especially in hypothesis testing. So, in fact, there are 4 possible situations in hypothesis testing. Okay, so this is the state of the world. Okay, so this is the state, which means you don't have any you don't have any effect on it, or okay, you don't have any let's say effect on it. You cannot decide on them. Well, for example, I assume we are talking about the lifetime of people. Well, it can be mu equal to 70, or it can be greater than 70 or smaller than 70. So either H0 can be true, which means mu equal to 70, or H0 can be false. Okay, so you don't know it. It can be true, it cannot be, it may not be true. Okay? So there are 2 situations, 2 states of the world, but you don't know it. So, but there are 2 options. Either it's true or it's not true. But these are the decisions. Okay, so this is something you decide. You may reject H0 or you may not reject H0. These are your decisions. Okay? So, well, um, so if if so let's think about this. If H2 is true, okay, so if the state of the world under the underlying in the underlying model, if mu is equal to 70, and if you do not reject H0, okay, then that's a correct decision. Okay, so if mu is equal to 70, if H3 is true, and if you don't reject H0, okay, you say that, okay, I can use mu is equal to 70, then that's a correct decision. Or if H0 is false, mu is not equal to 70, right? And you just reject H0 and you say that, well, H0 is not true, okay? Then that's a correct decision as well, okay? So these are 2 correct decisions. However, if H0 is true, okay, assume that mu is equal to 70, but you reject H0 and you say that, well, I reject H0 and I say that, well, mu is not equal to 70 or mu is greater than 70, then that's not correct, okay? So you are making an error there. And this is what we call a type 1 error, okay? So for the other one, for the last case, assume that H0 is false, which means, well, mu is not equal to 70, right? Mu is greater than 70, but you do not reject H0 and say that, well, mu is equal to 70, you can use it. So that's another error, okay? That's another error, and that's what we call type 2 error. So what is type 1 error? Okay. Okay, so type 1 error is reject the null hypothesis H when it is true. Okay, that's the error. So when it is true, just reject the null hypothesis. Type 2 error, do not reject it when it is false. Okay, so there are 2 types of errors. So a good hypothesis testing procedure should attain small probabilities for these 2 types of error. So as a statistician or as an engineer, what you should do is that before making the hypothesis, just choose your parameters so that the probabilities of making these 2 errors are as small as possible. So let's give the name alpha to the probability of type 1 error. Okay, so this is the probability of type 1 error. What is this? Probability that reject H0, okay, reject H0 if H0 is true, okay? We will also show this like probability that reject H0 given that. So this vertical line means that given that. What does it mean? So you are given an information which you can use in the probability calculation. What is the information? H0 is true, okay? So similarly, we will call the probability of type 2 error as beta. So let me just write it as blue since it's blue there. This is probability that don't reject, right? Don't reject H0, H0. Let's say when H0 is not true, okay, not true. And this is equal to probability that don't reject H0, don't reject H0, H0, given that H0 is false, okay, false. Well, please note that this alpha is in fact the alpha that we used so far, right? So it's also called the significance level. So, well, how it is associated with the extreme values as we just used before, we will see, okay? Now consider the following example, please. Assume that you have a shop in Taksim and you're selling mobile phone accessories, especially phone cases, okay? So iPhone 11 is just released and you want to purchase a large amount of iPhone 11 cases to catch the new demand of cases. Well, you know that the height of the cases are pretty standard and there are no problems associated with it. Okay, so this is the case, let's say, this is the case. Um, so the height, okay, so the height here, well, it's pretty standard, then hence you don't have any problem with this. But well, there's a serious problem with the width of the cases, okay, with the width of the cases. They can be very wide, which means that it stands loose and quickly gets out of the phone, okay? Well, it can be very tight, which means that it is hard or impossible to just put the phone into it. Okay. Um, so what you what you are doing is you decided to purchase 36 many cases at first and just make a test. If the width of the cases are 68 millimeters, okay, then you will purchase large amounts. Otherwise, you won't purchase them, okay? So again, so this is the case for iPhone, right? The height is okay. The height, that's okay, right? The height is okay. But so that's the okay sign. But the width, well, there's the problem with this. There's a problem with the width, right? So it should be 68 millimeters. If it is too wide, okay, if it is too wide or too tight, then that's a problem, right? So what you decided to do is you just purchase 36 mini cases at first and want to make a test. So assume that the standard deviation of the width is given as 3.6 millimeters. Well, also assume that one of your friends say that, well, he did such an analysis before, and we should not buy the cases if the average width of the cases, okay, is below or above 1 millimeter or more from the targeted value 68 millimeters. That is, he says, do not buy the cases if the X bar is smaller than 67 centimeters or X bar is greater than 69 centimeters, okay? So what you will do is, after purchasing 36 mini cases, you just take the average of them, okay? And if X bar is between 67, right, and 69, okay, then that's okay, right? You can purchase them. Otherwise, don't purchase don't purchase large amounts, okay? You just decide not to purchase large amounts. So our hypothesis is to test whether mu is equal to 68 millimeters, which means we will purchase, okay, so this is good, okay, versus we won't purchase, okay? So versus mu is not equal to 68 millimeters. If, okay, so, and we will reject the hypothesis if X bar is smaller than 67 or X bar is greater than 69, okay? Or we don't reject, okay, we don't reject if X bar is in 67 and 69. Okay? Well, recall in the previous hypothesis testing examples, well, we are given an alpha and calculated the left and the rightmost extreme values as our extremes, okay? Here, well, there is no alpha, but we are a sort of lucky because somebody has directly given us critical regions. Maybe he has an alpha and calculated the critical region from this alpha direct. Okay, who knows this? But as we said, we are lucky, we are given the critical region directly. Okay, so we are given the critical region directly, right? Directly give us, we are directly given the critical region. Okay. So let's define the type 1 error for this particular example. Well, do not buy the cases when their true width mean is 68 millimeters, okay? So the type 1 error here, what is type 1 error? Remember the type 1 error. Uh, Reject H0, okay, when H0 is true, okay, H0 is true. So H0 is true means that mu is equal to 68 millimeters, okay? So when the factories assume that you will purchase these cases from China, the factory in China is producing with the correct mean, but you decide not to buy from those cases. Okay, so this is type 1. Now calculate the probability of this type 1 error. Okay, so again, the probability of type 1 error, as recall, we just call this as alpha. This is equal to probability that reject H0 given that H0 is true. Okay. So what does it mean rejecting H0? Rejecting H0 means that you do not buy the cases given that the width of them is 68 millimeters. So when we do not buy the cases, if X bar is smaller than 67 or, okay, so this plus means or, if X bar is greater than 69, okay, so in fact I can just write it like this. This is probability that X bar is smaller than 67 or X bar is greater than 69, right? Given that the width of them, the width is 68 millimeters, okay? So in fact, I just missed a line here, okay? So after this, you can just write this or as this is equal to probability that X bar is smaller than 67, given that mu is equal to 68, okay, plus probability that X bar is greater than 69, given that mu is equal to 68, okay? Now I have just added this. So this is probability that do not buy the cases if the width of them is 68. Width of them 68 means that, well, mu is equal to 68 millimeters. Okay, so this is equal to probability that when you don't buy the cases, if X bar is smaller than 67 or X bar is greater than 69, okay? Given that mu is equal to 68. Now, this is X bar is smaller than 67 or X bar is greater than 69. So this is a probability. So you just add the probabilities just like this. X bar is smaller than 67 plus probability that X bar greater than 69. Okay, just like this. X bar smaller than 7 given that mu is equal to 68. X bar is greater than 69 given that mu is equal to 68. Now using the Sensor limit theorem, what we do is we just subtract the mean, okay? Just subtract the mean divided by the standard deviation, which is sigma over root 10. Okay, just do the same thing here. Given that mu is equal to 68, again, X bar minus mu divided by sigma over root 10, 69 divided by the minus mu divided by sigma over root 10, given that mu is equal to 68, right? So I've just written the same thing here. Now, uh, just replace sigma over root 10 with its value. So this is 0.6, 0.6 here, okay? And now, well, here I have mu, right? Mu, this is mu. But I'm given that mu is equal to 68, right? So here I have mu and mu here, okay, mu. So what I do is I just replace this 68, okay, to this mu here and here, of course, and here. And this is z, okay, and this is z, right? So what I have here is that, so if you just calculate this, so this is probability that z is smaller than -1 divided by 0.6 plus, so this is also probability, okay? I forgot to write it, p. So just give me a second so that I can just correct this. Okay, so I'll just added the probabilities there. Okay, probability, and then this is equal to probability that z is smaller than -1.67 plus probability z is greater than 167, and this is equal to 0.095. Okay, so what is this? This is the probability of type 1 error. Okay, so what does this mean? Even if the factory in China is producing with the correct mean, with mu equal to 68 millimeters, then with almost, okay, with almost 10%, I will reject the hypothesis and say that, okay, you are not producing with 67 millimeters, you are producing with an incorrect mean, hence I won't buy from you, okay, which is an error, right? You are just making an error. So here, the probability of committing a type 1 error, okay, or significance level of your test, of our test, is equal to the sum of the areas shaded here, okay? So remember, the probability that x bar is greater than 69, given that mu is equal to 68. So mu is equal to 68. So it's given that, which means the probability distribution has a mean of 68. So the probability x bar greater than 69, it's here. Okay, it's here. And the probability that x bar is smaller than 67, given that mu is equal to 68, it's here as well. Okay, so right, so the sum of them is equal to alpha, which is the significance level. So what does it mean? Since this is symmetric, so you see this 67, 68, and this is 69. So this is alpha over 2, and this is alpha over 2. Sum of them is equal to alpha, which is the significance level. Okay. So what does this mean? If we keep another, let's say, interpretation of this alpha, if we keep taking random samples of n equal to 36 from these cases, and if the width mean is in fact 68 millimeters, so if the factory in China is really producing with 68 millimeters, 9.5% of the time, okay, or almost 10% of the time, we would reject the correct H and don't buy the cases, even if the true mean is 68 millimeters, okay? So how can we reduce this error? Well, you can just take more samples, right? If you just take more samples, it means more data, then you may just reduce this error, okay? So let's try the same example with n is equal to 64. So now we have the standard deviation sigma divided by root 64, which is equal to 0.45, okay? So now the alpha is equal to, I'm just making the same calculations, except here I have sigma over root 10, which is equal to 0.45. Remember, sigma was 3.6, so this is 3.6 divided by 8, which is 0.45. So just make the same probability calculations, right? Using now with this sigma, okay? Well, it turns out that the probability is 0.0264, okay? So this is 2.64%, which is very small when you just compare with 9.5%, okay? That's much more smaller. So any other way to decrease type 1 error, okay? Well, we may change the limit of the critical regions, okay? So remember the critical region was this is what, this is 68. So one place is here, the other one is here, and remember the type banner is the area here plus the area here. Okay, so in order to reduce the type banner, what you can do is that, well, just move your critical region, for example, to here. Okay, let's say this is 63. Okay, let's say this is 63. No, not 63, but 5. Let's say this is 73. Okay, and this is the region. So the sum of this region is much more smaller. Just move your rejection region to here and here. Right? Right? Well, if you just calculate the same error, okay, with the same n is equal to 64, x bar minus mu. So this is now 63, now this is 73. If you just calculate this, you will see that alpha is equal to 0, right? Alpha is equal to 0. So there is no probability of making type 1 error, right? Making type 1 error. Okay, so in the next slide, so before getting into the next slide or next video, well, is there any problem associated with this? So why don't we use this? Okay, just think a little bit before getting into the next video.